Good evening. Today I am going to discuss about UJT, that is unijunction transistor. Unijunction transistor consists of a block of lightly doped N material with a P material grown into its side. It is often used as a trigger device for SCRs, that is silicon controlled rectifiers and triacs. Its characteristics make it very useful in many industrial circuits such as timers, oscillators, waveform generators and gate control circuits for SCRs and triacs. The UJT is a three-terminal switching device, that is emitter, base 1 and base 2. It operates in the mode of breakover, and UJT is a pulse generated with trigger voltage applied at emitter, and this voltage is a fraction of the voltage across base 1 and base 2. UJT is very different from a BJT. It was originally called a double base diode because it have two bases, base 1 and base 2. The first figure represent the schematic symbol and terminals names of UJT, that is emitter, base 1 and base 2. UJT connected into a simple circuit is shown in the second and third figures. This circuit diagram shows the emitter current IE, emitter to base 1 voltage VEB1 and base 2 to base 1 voltage VB2B1. The base 2 base resistance RBB is the resistance of the device between terminals B2 and B1 when I is equal to 0. In equation mode, it is represented as RBB is equal to RB1 plus RB2 when I is equal to 0. Here RB1 and RB2 are considered in the series mode. The magnitude of RB1 is typically from 5 to 12 kilo ohms. The resistance is fairly distributed between B1 and B2 when the emitter is open circuited. Due to the position of the emitter is closer to the base 2 contact than the base 1 contact, the magnitude of RB1 is slightly larger than the RB2 value. The resistance B1 is shown as a variable resistor since its magnitude will vary with emitter current IE. That is, the resistance of the lower divide is inversely proportional to the emitter current. When the PN junction is first forward biased, the junction resistance of RB suddenly appears to drop and rush of current occurs. Then we are going to see about operation of UJT. When the UJT is in off mode, no current will flow from E2 to B1. If VEB1 exceeds a certain value called VP means the amount of emitter voltage required to turn the UJT on, that is called VP, which is a certain fixed percentage of VB to V1 plus 0.6 voltage UJT is fired on. That means when VEB1 exceeds a certain value, the UJT will turn on. In this situation, E to B1 circuit becomes almost a short circuit and current can surge from E to B1, that is emitter to base 1 for very short time, and then the UJT reverts to off state. The value of VP will given by the following equation. Vp is equal to N into VB2 B1 plus 0.6 voltage. Here eta is called a standoff ratio. The value of eta is typically in the range of 0.5 to 0.8. It represents the ratio of RB1 to RBB with no current. And the 0.6 voltage is the forward turn on voltage across the silicon PN junction which exits between the emitter and base 1. We are all know that when the PN junction is forward biased up to the 0.6 voltage, it will show only 0 voltage and the forward characteristics. After the 0.6, the current will vary gradually. So that is the 0.6 voltage. So here this 0.6 voltage represents the forward turn on voltage across the PN junction. Then the characteristics of VI characteristics of UJT. Here when applied emitter voltage VEB1 is smaller than the peak point voltage VP, the PN junction at the emitter is reverse biased and only a small leakage current normally flows in the emitter. The current IEO, usually measured in milliamps, corresponds very closely with the reverse leakage current ICO. That is mentioned in the graph. And when EB1 reaches VB, that is the peak point voltage, the PN junction become forward biased and IE begins and UJT is turned on. After turn on of UJT, it operates in a negative resistance up to a certain value as shown in the uh, characteristics curve. As can be seen, after the peak point, VE decreases as IE continues to increase, thus producing the negative resistance characteristics. The negative resistance characteristics is a property of some electric circuits where an increase in the current entering a port results in a decreased voltage across the same port. This is in contrast to a simple ohmic resistor which exhibits an increase in voltage under the same conditions. Negative resistors are theoretical and do not exist as a discrete component. However, some types of diodes can be built that exhibit negative resistance in some part of their operating range. UJT is one of the type negative will exhibit negative resistance characteristics. So, because of this characteristics, it has many applications. As we have discussed earlier, it has many applications. Thank you.